So now we're going to talk about how to handle an exponential equation where you absolutely cannot make both sides of the equation have the same base. So at the bottom of page 5 of the 6.6 notes, I have the steps outlined in a box, and we will read through those in just a second. But first, let me show you the first one we're going to do. Okay, so this is example 5 on the next page. So 4 to the x is equal to 7. This is an exponential equation because x is in the power. There is no way you can make the bases the same on both sides. There's no way that you can rewrite 7 as a power of 4, nor can you write 4 as a power of 7. Okay, there's no way you can make the bases the same on both sides. So we're talking about what to do. Okay, so in this box, here are the steps that you need to take to deal with a situation like this. Okay, it says in step 1, if necessary, isolate the exponential term on one side of the equation. Okay, so meaning whatever quantity has x in the power, you need to isolate it, get it by itself. If you need to move things to the other side to accomplish that, then you need to do that. Okay, then what you're going to do is take the logarithm of both sides. Okay, we are going to use either natural log or log. Okay, now we learned when we did logarithms, there's tons of different bases for logarithms, but remember, natural log and log are the most common ones you see in math, and those are the ones that you have buttons for on your calculator. So that's what we're going to stick to, either using ln or log. It actually does not matter which one you use, okay, and you will see that. Sometimes it is beneficial to use one over the other, but we will talk about when that happens. But no matter if you use ln or log, you should get the same answer. Okay. All right. Once you take the logarithm of both sides, you're going to apply this property. Okay. I have it written here for the natural log, and I have it written here for log. Same property. Okay. This is what we learned in section 6.5, that if you have a logarithm raised to a power, you can bring that power down in front. Okay. So we will use that property. And that is going to get the exponent, or it's going to free the variable from the exponent. So that's why we're doing that. Okay. After you do step 3, you will no longer have a logarithmic equation, and you will be able to solve for x. Okay. Again, this is going to be an exponential equation that you're solving for. Since the domain of an exponential function is all real numbers, you are reminded in step 5 that it is not necessary to check your equations. Okay. Just a word of warning here. Some of these, when you solve them, your answer is going to look very strange, okay? Because you're going to have to give it an exact form. And then if it is a funky answer, you're going to have to give a decimal approximation. The exact form is going to look weird because it will involve a logarithm, okay? So don't second guess yourself, okay? You're probably correct, okay? All right, so let's take a look at this. Okay, so in example 5, I have 6 different exponential equations that we are going to solve. Okay, so let's start with part A. The directions say to solve each exponential equation and express irrational solutions in exact form, meaning no decimals, and as a decimal rounded to 3 decimal places. So you're used to those directions by now. All right, the first one. All right, we have 4 to the x equals 7, and this is the one I showed you a couple minutes ago, okay? This is exponential. The x is in the power. It's an equation. You've got an equal sign, so it makes sense to solve for x. What we're used to with exponential equations is getting the same base on both sides of the equal sign, okay? If that happens, if you can do that, then that's probably the easier way to go, okay? If you can't, like in this situation, there is no way I can rewrite 7 as a power of 4, and there's no way I can write 4 as a power of 7, okay? So what you're going to do, like if you follow the steps in the box on the last page, okay, you're going to identify what contains the x. Well, that's just the 4, okay? This is your exponential piece. That's what contains the variable in the exponent, okay? You want to isolate that guy, okay? In this case, it is already isolated, okay? But like if you look at part B, it's not exactly isolated because You got this plus 5 attached to the exponential piece. Okay, so you would have to do some work there. Okay, but in this example, the 4 to the x is by itself. Okay, all right, so what you're going to do is you're going to take the logarithm of both sides. Okay, it does not matter if you use ln or log. I'm actually going to work it both ways to show you that. Okay, so I'm going to start with natural log. Okay, so remember, when you take the logarithm of something, it is something you do to what follows. The logarithm has to go on the left side, otherwise it does not make sense. Okay, whatever you do to one side, you have to do to the other side. Okay, so this is what you end up with. Okay, now remember, if you look at the right side is no longer 7. It is the natural log of 7. If you punch that into the calculator, which we're not going to do quite yet, that is a nasty decimal. So we're just going to leave it as the natural log of 7. Okay. All right. So on the left side, we are left with the logarithm of something to a power. Okay. And we learned in section 6.5, if you have the logarithm of something to a power, the power can come down in front. So this is going to become x times the natural log of 4. Okay, that is still equal to the natural log of 7. Okay, so now we want to solve for x. Okay, x is out of the exponent. Okay, and so it's pretty easy to isolate it so that we can solve for it. Okay, one thing you should notice. Okay, and like I said, we really should save the calculator for the end, but I'm showing you here because this is your kind of your first time through this. Natural log of 7, just a number. Natural log of 4, just a number, okay? So what you have here is you have x times some funky number is equal to a funky number, okay? So treat these guys, even though they look strange to us, they are just numbers. If you have x times a number, to get x by itself, you're going to divide both sides by that number, okay? Whatever you do to one side, you have to do to the other. So the answer is going to be, these will cancel. The answer is going to be x equals the natural log of 7 over the natural log of 4. Okay? This is the exact answer. Okay? And by the way, the natural logs do not cancel. They do not cancel. Do not cancel the natural logs and tell me this is 7/4. Okay? The natural logs are there. They do something. The natural log does something to 7 in the top and makes it a crazy number. The natural log in the bottom does something to 4 and makes it a crazy number. So that is your exact answer. If I went to the calculator and I punched this in to get a decimal approximation, because you're asked to do that, okay, you would do the natural log of 7 divided by the natural log of 4, okay? By the way, you cannot do the natural log of 7/4. It's not the same thing, okay? So here's the decimal approximation. We're going to round it to 3 places after the decimal. So we've got 0.403. That 6 is behind the 3, so we need to bump it up to 1.404, okay? So we're going to say, we're going to put an equal sign here because it's actually equal to this. And then it is approximately 1.404. So that's the decimal approximation. Okay. All right. So that's what you do. Okay. I am going to rework the problem, but I'm going to use LOG. Okay. You're going to get the same answer. Okay. So let's watch this. Okay. All right. So if I did this with log, so I'm going back to the original problem. Okay. And I decided, hey, I'm going to use LOG instead. So I would have the log of 4 to the x is equal to the log of 7. Okay, so if you guys notice, remember when we were at this step, when we were doing it with ln, okay, we had ln of 7 and we had log of 7. Okay, if you look at your calculator, ln of 7 and log of 7, they don't give you the same things. Okay, but watch, this is going to work out to be the same solution for x. Okay. All right. So over here, all we did differently was take the log of both sides instead of ln. Okay. So again, on the left, you've got the logarithm of something to a power. You can bring this power down. Okay. So we've got x times the log of 4 is equal to the log of 7, okay? If you type into your calculator, both log of 7 and log of 4 are going to be crazy decimals, okay? Again, this is just x times a number, okay? X is out of the power now, so you can solve this for x by isolating the x, okay? So if you want to undo x times a number, you're going to divide both sides by that number. So we're going to divide both sides by the log of 4, okay? These guys cancel. I mean, it's completely parallel to the using ln, okay? So you're going to get that x is equal to the log of 7 divided by the log of 4, okay? So this is another way you can write the exact answer. Yes, it does not look the same as this one because one has ln and one has log, but they are actually the same number. Watch, okay? I'm going to get my calculator, okay? I'm going to type in, oops, I'm going to type in log of 7 divided by log of 4, okay? I get that same decimal approximation that I got before. Look, when I had natural log of 7 divided by natural log of 4, okay? Same number, okay? So either way you do it, you get the correct answer, okay? Even though they look different. And again, here it's the same decimal approximation. X is approximately 1.404, okay? All right, so again, when you do these, if you get a crazy looking answer, you've got to put the exact answer, which is this, no decimals, and then a decimal approximation. All right, so that is part A. Okay, let's take a look at part B. Okay. All right, so for this one, okay, it's an equation, got an equal sign, makes sense to solve for x. X is in the power, okay? Only one of these three terms has an x, which is this one, okay? So this is what we need to isolate. You need to isolate the exponential piece. So the base and the power, that's what you need to isolate. The base and the power, okay? So we're going to isolate this 2 raised to the x minus 7 power, okay? All right, so to do that, okay, I need to move over this 5. So let me go ahead and rewrite the original equation. Okay, I've got to isolate this dude. Okay, so since this guy, we're adding 5 to it. To undo that, we're going to subtract 5. Whatever you do to one side, you have to do to the other. So we're going to get 2 raised to the x minus 7 power is equal to 5. Okay, now this guy is isolated. Once it's isolated, then you can go ahead and take the logarithm. Okay, again, as you saw in part A, it does not matter if you use ln or log. Okay, I'm going to just use, I'll use ln. Okay, next time I'll use log. It doesn't, there are a couple of instances, and I'll tell you when it does actually matter. But for right now, I'm just going to do ln, but you would get the same answer if you used log. Okay, so in the next step, I'm going to take the logarithm of both sides. And again, you can't take the logarithm until the exponential piece is isolated. Okay, so in the next step, we're going to do the natural log of 2 raised to the x minus 7 power is equal to the natural log of 5. Whatever you do to one side, you have to do the other. Okay, all right, so then on the left, I've got the logarithm of something to a power. The entire power is going to come down, okay? It is a package deal, so I've got to put it in parentheses, okay? That power is multiplied by the natural log of 2, which is a crazy number, okay? The right side is the natural log of 5, which is a crazy number, okay? All right, so now what you can do, okay? All right, I need to solve for x. X is out of the exponent, so that's great, okay? So we're going to try to isolate the x. So what we have here is x minus 7 in parentheses times a number equal to a number. So the easiest way to get x by itself, okay, since we're multiplying by this number, we can get rid of it by dividing by it. So whatever you do to one side, you have to do to the other. Okay. So then the natural logs of 2, remember those are decimals, they will cancel. Okay. So that is going to leave you with x minus 7 on the left that is equal to the natural log of 5 divided by the natural log of 2. Okay, again, this is not the same thing as the natural log of 5 halves. Okay, totally different answer. Okay, all right, so x is almost by itself. Okay, to undo subtracting 7, you're going to add 7 to both sides. Okay, so your final answer is going to be the natural log of 5 divided by the natural log of 2, that quantity plus 7. Okay, so here is your exact answer. Okay, and then we can go plug it into the calculator to get a decimal approximation. Okay, so let's do that. All right, so we are going to get, let's see here, we're going to get natural log of 5 divided by natural log of 2. Okay, so you got that fraction, and then you're just going to add 7. Okay, so we're going to round it to 3 places after the decimal. So we've got 321. The 9 after the 1 makes us bump it up to 322. So x is approximately 9.322. Okay, so there you go. Okay. I'm sure somebody out there may have been wondering this question, okay? Since this, what we started with was a base 2 exponential, why didn't I use log base 2? Because 2 to the x and log base 2 of x are inverse functions of each other. And my answer to you is you can do that. You can use the logarithm of any base as long as you take, if you're taking the logarithm of both sides, whatever you do to one side, you do to the other. The problem is when you come down to get the decimal approximation, log base 2 of x is not readily available on your calculator. The popular things on your calculator are LOG and LN. And so that's why when we're solving these problems, we're sticking to doing LOG or natural log, okay? So my point is you could use those other bases. It is not incorrect. It just may be a little troublesome. If you're trying to get a decimal approximation out of the answer, you might have to like kind of dig for it in your calculator, or maybe you have a calculator that doesn't do it. Pretty much all the calculators do natural log and LOG, so that's why we're sticking to using those particular logarithms. Okay, all right, let's do the next one.